Hi, I'm Bharti. Today I'm going to be discussing Big Data Technologies Assignment 3. This is the assignment file. First, I'd like to give you some introduction about the assignment. So this assignment is for the investigation of New York City taxi data set for the month of January, March, and June. Is the goal of this data analytic research. The main goal is to use organized approach to find pattern trends in these databases. The following crucial phases are included in this approach is data loading. The first step is to load the New York City taxi dataset into pandas data frames for the designated months. This makes it easier to manipulate and analyze data effectively. Then comes data understanding. The supply data dictionary is Price's tool for assisting the precise data interpretation. It clarifies the purpose and importance of every column, assisting with a thorough understanding of the dataset. Then we'll move on to comparative analysis. This analysis main objective is to compare data from the months of January, March, and June. The goal is to identify three key patterns that shed light on workings on New York City taxi industry through analysis of this data set. Various factors such as ride volume, trip duration, payment option, and more may be included in these trends. The goal of this analytical project is to offer insightful information about how the New York City taxi services behaves in various months and seasons, which may help in decision making. So our first task is using these yellow taxi trip records from January, March, and June 2023 and loading them into our file. So first task is data loading. Here is the data loading. This is for the month of January, this is for the month of March, and this is for the month of June. So for the month of January, these are the first 5 rows of data frame, which are shown as an output, and same for March and same for June. Then we'll be doing the trend analysis. Then we are going to analyze the trends. First is trip volume. So here, as from the pie plot, you can see that the trip volume comparison in January, June, and March. March having the highest, so the total number of trips shown an upward trend from January to June with a slight decrease in June compared to March. Then second trend is average trip distance. The data indicates a gradual rise in the average trip distance through the year, with the shortest average distance occurring in January and the longest in June, as we can see from the point plot. Then is third trend is payment type distribution. Here, most payment, how they are made. So the most payment that this data shows that rising trend is the use of credit cards for payments for the month of January through June, along with the concurrent increase in cash payments. This shows that at this time, there was growing demand for non-cash transactions. Then is the task 2. Task 2 from the guidelines says that data exploration and pre-processing. Here we'll be finding missing values. We'll be finding 2 columns that have noisy erroneous values, and then identify 2 columns are highly correlated and explain their correlation. So this is the data exploration and pre-processing, checking for the missing values. These are the missing values. So there are total 71,743 instances of January to 2023 data set where data in the following columns is either missing or incomplete. Then comes for the 2 columns that have the noisy erroneous values. And then, sorry for that, let me check why it is giving me. Sorry about that. So this is import the plot library. So yeah, and there comes the heat map for the correlation matrix. So there's a substantial link between the fair amount and the total amount, which makes sense given the total amount includes both fair and additional expenses like taxes and tips. So the two prominent pairs of highly correlated columns can be found in the correlation matrix. There is total sum and fair amount. Improvement surcharge and the MTA tax has the most correlations among all the attributes. Then comes our task 3, featureization. So for the first featureization, we'll be checking for the rush hour flag. So these are the rush hours and these are the non-rush hours. And here's the pie chart showing the rush hours versus non-rush hours. So from the findings in the January month, these much trips are done in rush hours and these trips are done in non-rush hours. Then comes the trip complexity. This is to derive the geographical center every taxi zone. And for all the taxi zones, this is the centroid map for showing the taxi zone with the centroids in New York City. And this is the map for New York City. And you can find all them. Yeah. Then comes determine direct point-to-point distance, and then pickup of drop-off of frequencies. Then comes task 4, data analysis. Then first data analysis we done is the rank the vendors by popularity. So vendor ID and data type, these are 2 in 1. Then comes the vendor popularity ranking. And from the ranking, after that ranking, we check on to the peak travel hours. Then these are the peak travel hours. Then average trip distance on weekdays versus weekends. This is the histoplot plot for weekdays and versus weekends. Then comes average number of passengers weekdays versus weekends. And this is the bar plot for, this is the his plot for the distribution of number of passengers weekdays versus weekends. Fifth is the correlation between fare amount and trips, and the correlation between fare amount and the number of passengers. Then comes our conclusion, and the key findings are spatial distribution, seasonal variation, vendor popularity, analysis of weekdays versus weekend journeys, peak travel hours, fare analysis. I also come across few challenges while doing this assignment, that is the data security and privacy, data quality, missing coordinates, data size, and many more. But these are the major ones which I personally faced. Then comes the additional possible analysis that can be done for the same, and to elaborate our analysis more is the seasonal analysis, route optimization, congestion analysis, customer segmentation, geospatial analysis, rate type analysis, payment type analysis, and many more. So to end with my assignment, I would like to conclude that examine the New York City taxi data offers through thorough insight of the city environment and the habits of both locals and tourists. Going much beyond simple math calculation, the analysis conclusion provides stakeholders the capacity to make data-driven decisions that will ultimately improve service quality, increase operational effectiveness, increase profitability. This data is essential for ongoing development and improvement of taxi services cities that is a dynamic and ever-evolving